Scott Vlashin is joining us here. Let me see if I can grab Scott. There we go. Hey, Scott.
Hi, Jeff. How you doing?
Good to see you. Now, I heard a number of the folks in that keynote talk about F sharp for fun and profit, and I
Yep,
understand that's your website.
that is my website. Yes, and so I started that about 8 years ago now, and I was learning F sharp myself, and I thought, while I'm learning, why don't I sort of write up what I learn as I learn it? And it turned out it was very useful for me. It kind of forced me to be, to kind of dive into things, but it turned out to be really useful for a lot of other people as well, and that makes me very happy. I'm glad that a lot of people find it useful. Yeah.
Oh, that's terrific. So you're gonna be going over some of the basics here for us to get
Yes.
folks started.
Yep.
All right. If
And
you want
I'm
to share your
just
screen,
going to share my screen. Here we go.
there we go. And what's going on there? Let me try. I'm getting some visual artifacts coming through. There it is. Fantastic. All right, Scott, the stage is yours.
Okay, thanks so much. Right, so this is the first sort of technical talk of the day, and I'm trying to think what can I do in 20, 25 minutes that can be useful for everyone. So I just thought I'd just cover the basics of F sharp. What do you need to understand in order to watch the rest of these talks today? And also, if you just want to start playing with F sharp yourself at home. Obviously, I can't do too much, but I thought what I'd do is I just go over the syntax. I'd go over the use of functions as the sort of building blocks of things. I'll talk about pipeline-oriented programming, which is a sort of different way of programming than you're used to if you're an object-oriented programmer. And I'll talk about F sharp's composable type system. Now, F sharp supports all the object-oriented features that C sharp does and object-oriented languages have. But in addition, it has another type system, which is the composable type system, which is really, really good for domain modeling. And I think I can just give you a glimpse of that too. So I am going to just go into a demo mode now. I'm going to be using VS Code. I'm using the Ironide extension, which is the standard F sharp extension for VS Code. And the code is on GitHub. For anyone who's watching this later on, you can download it and follow the talk later on. So let's start with Hello World. So I'm just going to create a new file, and I'm going to call it hello.fsx. And there we go. Now, F sharp actually has a number of different ways to work. I am going to normally show you the sort of interactive way of working, but you can do interactive code, you can do scripting like Python and Ruby, and you can also compile a bunch of F sharp files into a single executable or a library, which is just like you would with C sharp or Java. So you've got a choice of different ways of working. Like I said, I'm mostly going to use the interactive mode, and what you do here is you can just highlight individual little bits of code and hit Alt-Enter. And I think Alt-Enter is actually the same keystrokes in VS Code, in Visual Studio, and in JetBrains Rider, which all have really good support for F sharp. So I'm going to hit that, and it's going to start up an F sharp terminal down here, and it says the name equals world. Okay, and now I do the next line, and there it is. It prints that line. So okay, very exciting. But there you go. This interactive F sharp code. Often when people are working with F sharp code, we actually kind of play around with things interactively, and then when we're happy with it, then we kind of put it into a compiled format for deployment. Now let's try the script one. I'm just going to change it so it reads it from the console. So now I'm going to go over to the command line, and I'm just going to say .NET FSI hello.fsx, and that should run this as a script, just like a Python or Ruby script or Perl script or something. And it should ask me for my name, and there it is. And there it prints out hello Scott. So that's basically, you could, that's just a few minutes just to get started with F sharp for playing interactively. Now, let's start with some syntax. Okay, so obviously there's more to F sharp than that. The first thing you want to do when you're learning a new language is how do you define variables? How do you define functions and so on? So in F sharp, it's the let keyword, let something equal something else. So here you have let x equals 42. Now, in F sharp, the defaults are very different from most other languages. Everything is immutable by default. Most things are not allowed to be null by default. So no nulls, no mutation. That's sort of the default way of doing things. So this x, once you've assigned it to 42, you can't really ever change it again. Now, if I do this interactive thing where I do Alt-Enter and I show it down in the interactive terminal down here, you can see it says x:"int equals 42. So let me explain how to interpret that. So x is a value, colon, every time you see the colon, it's something to do with a type. So type :"int" means it's of type integer, and of course it's equal to 42. Okay, well that's straightforward. Now what about functions? So what's interesting is in F# you use the same keyword for functions, let, because functions are things just like strings and ints. I mean, it's a functional programming language. Functions are treated just like every other thing. So here I have a function called add. Now, a couple of things I want to point out is, first of all, we use spaces. It's got two parameters. We use spaces. We do not generally use parentheses and commas like that. That's not really the standard way of doing it. Sometimes you might do it that way, but in general we don't. The other thing, there's no return keyword, right? I don't need to say return. That happens automatically. And if I do Alt-Enter on that, there it is. It's interpreted this as the function add. I'm looking down here, and it's x is an integer, y is an integer, and the return type is an integer. Okay, and if I want to run the code, again, when I call the function, I put spaces between the parameters, not normally commas and parentheses. So if I add 2 and 3, it says the answer is 5. Now, sometimes you do put the parentheses, comma thing. That's typically when you're calling object-oriented code, for example, the .NET library. But normally inside F#, we tend to use the space type thing. And there's a reason for that, is because we can miss off certain parameters and add them on later on. It's a very cool feature called partial application, but I'm not going to have time to talk about that today. Okay, now what happens if you have a little bit more of a complicated function and you need to have a big block of code? So in F#, just like Python, blocks of code are done through indentation, and you do not need the curly braces. So, this piece of code belongs to this function. These 2 lines of code here belong to this function. These 2 lines of code here belong to this function. So it's pretty straightforward how you do it, right? I mean, you don't need the curly braces to decide how it looks. And if you can define, inside your main function, you can define sub-functions and so on. And again, you can just indent, or if you have like a for loop or something, you can just indent for that as well. So everywhere you'd use curly braces, you just use indentation instead. So if you want to convert from a C language to an F# language, you basically follow these instructions. You use let. You basically indent how you normally would, and everything's going to work, right? You don't have to do anything weird. But you do have to delete the curly braces, delete the return, delete the semicolons, and delete all the type annotations, because they're mostly not needed. So F# is a lot more succinct than a standard C-type language. So let's try it on this one. Here's like C code for that same thing that I had above, which is squaring something and then doubling it. So I'm going to use let, and I'm going to put equals. Okay, get rid of the curly braces, get rid of the return, get rid of the semicolons, put a let there, get rid of the parentheses, and I can get rid of the int there because it's going to figure out there's an int automatically. That's how you do it, how you convert C to F#. So the syntax is obviously different if you're used to a C* language, but it doesn't take that long to get used to. Most people can learn it, in a couple of days. It becomes more comfortable. Now, if you're coming from Python, of course, Python and F# are sort of cousins. So you just have to replace some of the keywords. Def becomes let, and the colon becomes equals, and you need to put lets in. There you go. That's kind of the Python turned into F#. Really, really similar. If you're used to Python syntax, then F# syntax is really easy. Right, now, I just said that we don't use, curly braces. Almost certainly in the rest of today's talks, you're going to be seeing curly braces. So what is going on there? I'm not trying to lie to you here, but I just want to show you why you would use these curly braces and what circumstances they show up in. And they show up when you have, the curly braces don't show up on their own. They normally have a word in front of them, like this one says async. So this, when you see async followed by some curly braces, everything between the curly braces is a special block of code that we call a computation expression. And inside that computation expression, you can change the behavior of the compiler. So you can change how assignment is done. You can change how loops work. You can change all sorts of kind of interesting things. So for example, in the async computation expression, we've overridden the let. This is the special syntax let bang and do bang. And we override it so it becomes basically the same as await in C#. So if in C#, if we had some async code, we wanted to do an await on it, we'd write something like that. In F#, we use the let bang and the do bang. Now, the async expression is not part of the F# compiler. It's just a library that you can use. And there's all sorts of things you can do with computation expressions. You can use it for async, and you can use it for tasks. You can use it for like query expressions in C#. You can use it for generating, collections. You can do validation, error handling, testing, code generation, all sorts of things where you want to sort of change the default behavior of something. So I've got some examples here. This is a sequence. So this is a sequence computation with an SEQ. And every time in this block of code, you can generate sequences in all sorts of nice ways, like using loops and so on. Here is a query expression, query with curly braces. And inside the query expression, you can do, the queries where, for student in this database, filter them and sort them and select them and stuff. And so, and like I say, this is not hard coded into the F# compiler. This is anyone can write one of these things and just use it from a library. So all these things are actually just are accessible, easily accessible through just importing a library in F#, and you can write your own. Right. So if we have a more complicated situation where we have a function calling another function, which is a very common situation. If I said, for example, I want to square something and then I want to double it and then I want to add 42 to it or something, in most languages, you would write it like this. You'd have these nested functions with nested parentheses. In F#, we actually would not write it like that. We would use what we call the pipeline operator. And it looks like this. It has this vertical bar with a angle bracket. Now, if you're used to Unix pipelines on the command line, it's exactly the same thing. It's taking the output of one thing and piping it into the input of the next thing. So, for example, I'm taking this x and I'm feeding it into the square function, and I'm taking the output of the square function, I'm feeding it into the double function, I'm taking the output of the double function and feeding it into the add 42 function, and so on and so forth. And you can chain more and more functions together to make bigger and bigger pieces of code. So this is the most common way of making bigger pieces of code from smaller pieces of code. And obviously, as they get too big, you might want to like put them on new lines. And so you can end up your code kind of looking like this, where there's a vertical pipeline rather than a horizontal pipeline. So this is very cool. Now, if you're used to LINQ in C#, you'll probably be familiar with this way of working, because LINQ works exactly the same way. So in this is actually LINQ in F#, because LINQ F# supports .NET stuff. So this is the LINQ select method, the LINQ where method, LINQ select, and so on. And we're just kind of transforming a list of numbers into various other things. And here I am multiplying each number by 2, and here I am filtering where the numbers are less than 6. Now this syntax here, the fun x arrow x times 2, that is the F# lambda syntax for lambda expressions or anonymous functions. And it's slightly different. Each language obviously has a slightly different way of doing it. In F#, we decided to use the fun keyword because fun is really important to have in F#, right? It's super important. So in F#, however, we would not use the LINQ approach because it's already built in with the pipe. So we would use this second approach much more than the LINQ approach, which is basically exactly the same thing. I'm taking these numbers, I'm feeding it into this map function. I take the output of the lists and I feed it into the filter function. I take the output of the filter and I feed it into another map function, and so on and so forth. So I can build chains of functions in the same way that I would use if I was using LINQ. So there is a difference between using LINQ and using the F# pipe, however, because I think that the pipeline approach is actually a little more flexible. You don't need to create extension methods all the time. You can take any old function from anywhere in your code and stick it in the pipeline. So I've got 2 new functions here, one which just multiplies all the numbers together, and here it kind of logs it to the console. And I can just stick them at the bottom of the pipeline. Right here, I'm putting the product one in, and here I'm putting the console one in. And as long as the output of the previous function matches the input of the next function, and they can be connected together properly, then it works great. And if the inputs and outputs don't match, you'll get a compiler error, which is very nice. So you're not going to make any silly mistakes that way. So this actually brings me up to talking about Solid, right? So Solid is these object-oriented principles, and you don't normally think of them as sort of functional programming principles, but they actually work really well with functional programming. For example, the single responsibility principle Well, that is exactly, you can't get more single responsibility than a function. A function just does one thing. So the one I want to just quickly mention, though, is the open-close principle. So the open-close principle says basically you can add new code to something, but you shouldn't change existing code. Don't touch code that's working. You can add code around it, but don't mess with the code that's working. And that fits really, really well with this sort of pipeline approach to doing things. So let's say that I have my, this little piece of code I had here where I'm multiplying things by 2, and I decide that I really want to like productize this and start have a unicorn startup based on this feature. How would I kind of make it more serious? Well, I would want to load it from a database, and I'd want to save it to the database and add logging and so on. So this is what I'm doing. I'm just adding some extra stuff in front. I'm loading it from the database. I'm deserializing it. I'm doing my pure domain logic, serializing back again and saving it back to the database. And one of the things you might notice about this is it also fits really well with the onion architecture or the clean architecture, the hexagonal architecture. All these architectures have the idea that your core domain is in the middle, and anything which is to do with I/O or anything which is sort of non-deterministic goes on the outside. And functional programming, this fits perfectly. This is my I/O stuff, my non-deterministic stuff. It's very hard to test this stuff. My pure domain logic is very easy to test, to do unit tests. And then again, I do some I/O stuff. So I do an integration test would be the whole thing would be the integration test, and the middle bit would be the bit I would unit test. And of course, because it's a pipeline, I can do some other things. So let me add some logging. Okay, I want to log everything. So I don't have to change any existing code. Right, I'm going to follow the open-close principle. I'm not changing any code. I'm just adding new things to the existing code, but I'm not touching any of the original code. And I mean, I can do anything. I mean, I can literally put anything. Let's say it's really important that nobody is allowed to multiply by 2 unless they're authorized. So I'm just going to add an authorization step into this process. So as long as the inputs and outputs match, they all stick together. Now you'll see, I think later on, you'll see some web applications designed in exactly the same way. You take the input from the web, you check the authorization, you maybe deserialize it from JSON, you do your domain logic, and then you put it in the database and stuff. The web apps can be written in exactly the same way, because a web app is really, a web API is actually just a giant function with an input and an output. Okay, one more thing about syntax before we get onto the types. And I just quickly want to talk about how type inference works. So here is a function called add2. And notice that I've specifically said this is an integer, and I specifically said that the output is an integer, and so on. Now, this is another function which looks really similar. It does basically the same thing, but I haven't had any type annotations at all. And yet, it's figured out that this is an int and an int function. So both of them are exactly the same kind of function. They both have integer input and integer output, but one of them I annotated and the other one I didn't. And I don't normally need to annotate my functions. I would annotate them with types if it's like a public API and I want to do a documentation, or it's like an interface or something. But in the middle of our code, we often don't bother to do the type annotations because it's just extra noise, right? So let me show you how it actually works, because a lot of people think it's somehow it's magic. It's not actually magic. It's really easy to understand. So here is a very kind of silly function. It's called do something. There are 2 parameters. There's an f parameter and an x parameter. And the question is, what is f and what is x? And I haven't said anything about what it is, and yet the compiler has sort of figured it out. So the way the compiler thinks is like, well, okay, this is an int, 1 is an int. I'm adding x to 1, so x has to be an int. And F# is very strict about this. You can't add floats and ints together. So if you're adding something into an int, it has to be an int. Now, this y here, this is being added to a string, so y has to be a string, okay? Now, f here is a function, and the input is x plus 1, which is an int, and the output is y, which is a string. So f must be a function that has int as input and a string as output. And if I test this, lo and behold, there it is. It says f is the f parameter is a function, the x parameter is an int, and the output is a string. So it's basically working just how we expect. What's nice about the type inference is it's dynamic. If I change this to a float, now if you can see the kind of tooltip thing here, it says it's now a float. Or if I change it to a string, now the input is a string. Or if I change this to an equal sign, so the output is now a Boolean, are these 2 things equal? And if you look over here, you can sort of see that it's a Boolean. So it's really nice that it's sort of, very dynamic. It saves you a lot of time. Now, one other nice thing about the type inference is if you actually are if you're using this code, like here I have an int string function, and of course this has exactly this type that we want. It's going to turn ints into strings. So I can pass this in as a function parameter. Now, as soon as I change my code over here, I now get an error over here because it says, okay, this is not valid anymore because you're giving me an int string function and it's now wanting a float string function. And this is one of the nice things compared to something like Python is, you're getting compile time, you're getting immediate feedback if you've made a mistake. You don't have to wait until runtime. You don't have to even run any unit tests. It won't even compile if it's wrong. So you're getting, what I like about F# is it's got the sort of succinctness, it's concise, it looks like a scripting language because I don't have any types, but it's actually got this type checking that a statically typed language has, like C# or Java. So you're getting all the benefits of a static type language, but without all the noise of having all these extra types everywhere. And I'll just quickly go into a little more detail on that one, because people think of, not typing. It's like, I don't want to, it's less typing things out. Well, that's one thing, but like I said, the big benefit is actually less noise and more focus on the logic of what's really going on. So I've got an example of some C# code and some F# code. Now, this is the C# code for the group by method in the link library. And you can see there's the actual name of the method. And there's all this other stuff. It's an enumerable containing a grouping, which has 2 parameters, a key and a source and stuff. Now, the F# code doesn't have any of that. It just looks a lot easier to read. Now, it's just a statically type check. It's exactly the same type checking going on in both cases, but you just don't have to have it with the F# code. It just looks a lot nicer. It looks a lot friendlier to work with. So that's everything you need to know about the syntax and the sort of pipeline approach to programming. Let me just finish up with some types. So as I said earlier, you can do OO programming in F# no problem. It's got really good support for OO. In general, though, we use the other type system that F# has, which is called the algebraic type system, or I prefer to call it a composable type system, because the way you work with the types in this one is you build up bigger types from smaller types, just like using Lego, right? So you take 2 things and you make a bigger thing out of them. So the first kind of type, or the first way of combining things in this composable type system is using AND. And this is really common when you're talking about things. You say first name and last name, right? Or you say email and address, or ID and description. So this is a thing, and it's got an ID and a description. So we use the keyword here is type, not class. And we use curly brackets or curly braces to define a record. Now, this is nothing special. Like almost all programming languages have a sort of struct, right? It's a struct. It's a class without any methods. It's nothing. It's really not unique to F# by any means. So, but I'll talk about another one in a minute, which is a bit more unique. So here we have our record type, and if I want to construct one, I construct it in a very similar way to the way I define it. So when I define it, I say :int. So that I'm telling you that's the type of int. But when I construct it, I just say equals. So I'm actually assigning a value to the ID field, and I'm assigning a value to the description field. Now, in F#, these records are immutable. You can't change them. So the only way you can change it is actually make a copy of it and change one of the fields as you make a copy. And the way you do that is using the with expression in F#. So I take the original one, and I want to change the ID. So I'm going to use this with. So it's the exact copy of the original one with this extra field change. Now, you might say that's a lot of copying going on, right? All this immutable stuff is going to slow you down. It's going to be a performance problem. Actually, it turns out it's not really a performance problem in F#. First of all, with a generational garbage collector like .NET has, young objects that die quickly are actually collected very efficiently. So if you make a copy of something and the original one gets killed, that's actually more efficient than having an object that sticks around for a long time. But in general, C# and F# there's compiler optimizations, and there's various things that go on that make it quite efficient. Now, if you're really into serious performance, you can do structs in F# just like you can in C#, and that puts things on the stack instead of the heap. You can do all the things like spans and all that stuff, the zero allocation stuff that you can do in .NET. You can totally do it in F# just like you can in C#. So that's nice. One more record thing I want to show you is this. Sometimes you see a curly brace followed by a vertical bar, and that's an anonymous record. So that's a record where there isn't really a type definition. You're just defining the type definition on the fly. So I'm saying this is a name and an email, but there's no proper type associated with that. That's very good when you're kind of exporting things to JSON or something like that. You don't really want to create a special type just to hold this complicated JSON. You can just define it on the fly. Now, the other type of composition in the F#'s type system is what I call a choice type. And it's when you combine things using the word or. So I would say a primary color is red or yellow or blue, right? Red or yellow or blue. And you use the vertical bar to mean or. And the technical word for these things is discriminated unions in F#, but I like to call them choices because it's a choice of these three things. Now, you might say this looks awfully like an enum in most other languages, and in this case, yes, but the difference is that in F#, these choices can have data associated with them. So here we have a color, and there's three different choices. It could be a primary color, it could be an RGB color, it could be a named color. If it's a primary color, it's one of these things. If it's an RGB color, it has the data associated with this RGB struct, which I just defined up here. And if it's a name color, the data associated with it is a string. So in this case, it's more like having sort of three subclasses, right? Each subclass has its own little data, and they all inherit from the same thing. It's not really like subclasses, but you can use it in a similar way. The difference in F#, of course, is this is 4 lines of code rather than having 4 different files with lots and lots of stuff in each thing. It's like literally it's all in one place. And I actually really like F# for doing domain modeling, business type domain modeling. And I'll show you, I'll just finish up with an example of this. Let's say you have requirements to take a payment method. And you say, okay, we take cash, or we take PayPal, or we take cards, right? Now, for PayPal, we need an email address. For cards, we need a card type. There's different requirements. Now, most people, if you wanted to implement this, you'd probably say, well, I have a abstract base class, or have an interface class, and I'll kind of create 3 subclasses that implement that interface. In F#, we wouldn't do that way. We would probably do something like this. So here we have our payment method down here, and there's 3 choices: cash or PayPal, right? I'm using the word or, cash or PayPal or cards. And if it's PayPal, we need an email address. If it's a card, we need credit card information. Okay, so what's the credit card information? It's a card type and a card number. So I'm using the word and, right? So that's another way of building up things. That's the record type. And okay, so what's a card type? A card type is a Visa or a MasterCard. So by using choices, by saying and things and oring things together, I can actually build up a really sophisticated domain model in a few lines of code. And what's really nice about this is actually you can show this to non-programmers, and they can actually understand this. They can actually give me feedback. Did I miss something? So this is very, very clean, very easy to understand, but also very, very strict type checking, right? This is my domain model. I can't possibly, if I program to this domain model, I can't kind of have any errors. So I think that's pretty much all I have right now. So just to finish up, here's some things you can look at if you want to get moving on F# yourself. I would start at fsharp.org. There's a lot of good data there. That's the F#, the kind of focus for the non-profit, the community side of F#. The Microsoft Docs are good. I would recommend, if you're into F# is to join the F# Slack. You have to join fsharp.org, but it is free. But that gives you access to the Slack, and there's really lots of good information. People are very beginner friendly there, so don't worry about asking silly questions. If you're on Twitter, the F# hashtag is the place to go. If you tweet F# hash F#, you'll probably get lots of feedback from people. And finally, there's lots and lots of blogs and videos. For example, if you Google my name, if you go onto YouTube and look for my name, you'll see all my videos. And if you go to following me as Isaac, and if you look for his name on YouTube, you'll see all his videos. There's lots and lots of good stuff out there. So have fun with that. Thanks for joining. I don't think we sort of run out of time for questions, but do ask your questions on Twitter, and I will get back to you on Twitter. Lead you to anything. So,
oh my
gosh, thanks very much.
Wow, so much really good stuff that you covered there. And I'm seeing some comments from folks out in Twitter that are excited to try out some things, some great feedback and commentary from folks. I'm going to share my screen here real quick so that I can share and show a little bit of what folks are saying about. There we go. All kinds of stuff folks are saying out there under .NET Conf. Hashtag .NET Conf. You can ask your questions out there. Folks like Scott will answer your question. We've got some other moderators that'll help pull some of this together. Some great comments that I want to call out here real quick. Like Angel writes, Lambdas and F# are fun.
That is true. Fun is very important.
Absolutely. There was a really good question that came in from Vineet. Can we make mutable functions in F# since functions and values are the same thing?
You can't make a you can assign a function to a mutable value. So you can have mutable values in F#. You have to ask for it with the mutable keyword. But it's really weird. I mean, it turns out when I first started learning F#, I thought, well, how can you do anything without mutating values? That's just ridiculous. You can't possibly program without that. It turns out that you can. And it's actually really cool. Once you get the hang of it, it's actually amazing. And in fact, mutability becomes almost like a code smell. Sometimes you need it for performance or various things, but in general, if you see the mutable keyword, that means that you can probably rewrite it to be better than that. So it turns out you can actually write whole applications without using mutability anywhere, and that's awesome.
Very cool. Well, you're right. We are out of time. Thank you so much, Scott. Like I said, there's questions out there under hashtag .NETConf. Folks can ask, and we'll be triaging and sending them along, bringing in our speakers to answer out on Twitter and hopefully here on video. Scott, I hope you have a great rest of your day.
Thanks, Jeff.
And I will dismiss Scott. Take care.
See you later. Bye, everyone.